Like all programming languages, Python has a full slate of mathematical operators, including addition, subtraction, multiplication, and division. And of course, we can't forget exponentiation. So in this video, we'll walk through each of them in order so that you can understand exactly how to use them and how Python applies them within the Jupyter framework. Within Jupyter, let's create a new notebook dedicated to mathematical operators. So I'll say File, New, Notebook. And of course, I'm going to select my Python 3 kernel and then right-click, rename it. And today is July 7th, so I'll say 7.7, and we'll say Math Operators. So now I have a dedicated notebook for that topic. So let's go through each of the operators in order. The basic operators are what you would expect. Addition is plus, subtraction is a hyphen or minus, multiplication is an asterisk, division is a slash, and exponentiation is actually two asterisks or stars. So to apply them, we could do something very simple. We could say, for example, the price of an item equals $19.99, and then we could say the sales tax rate is, and I used to live in Texas, and the sales tax in Texas was 8.25%. If I run that, that will put that into memory. If I want to know what the sales tax then was on the sale, I could say sales tax equals the sales tax rate times the price. And that will, of course, give me the sales tax. Of course, in Delaware, we don't need to worry about this, but in other states, we have sales tax. If I run this now, I can confirm that the sales tax was $1.65, rounded to two decimal places. If I want to know then what I actually have to pay, I could say final price equals price plus, and then the sales tax. And if I run that and then print the final price, you will see that the total is $21.64. So this illustrates the basic math operations. I guess the only one I didn't really use here is the minus symbol, but I'm pretty sure you understand how to use that as well. But you'll see how the plus, the ampersand, the asterisk for multiplication all comes into play. If I needed to use the division symbol, for example, I could just say, in a simple example, y equals 6 divided by 4. And if I run that, it will give me 1.5. So it's a pretty basic operation. And of course, the subtraction is used in a similar manner. In a real-life example, suppose I wanted to convert Fahrenheit to Celsius in terms of temperature. I could start out by saying the degrees Fahrenheit are, let's say today's a nice day, we'll say 94.2 degrees. And I'll put that into memory by hitting Shift Return. To calculate the degree Celsius, I then could say degrees underscore Celsius equals, and then it's 5 divided by 9 times the degrees Fahrenheit minus 32. Now, just like any other mathematical expression, I need to be very careful here because the order of operations is important. I need to actually do the degrees Fahrenheit minus 32 first. So I'm going to put parentheses around that quantity, and that will ensure that the calculation is correct. If I then run this, and then I print out the degrees Celsius, you'll see that the result is 34.56 degrees Fahrenheit, Celsius rather. In another example, I might want to find the length of a hypotenuse, which of course is the side of a triangle opposite a right angle. If I have the two legs of the triangle being, let's say, 3 and 4, I could find the length of the hypotenuse of a right triangle by using the Pythagorean Theorem, and I'm sure you've used that in geometry. So as an example, I could say leg 1 equals, let's say, 3.0. Leg 2, let's say, is 4.0. What is the hypotenuse? Well, if I hit Shift Enter and run that to put that into memory, I can then calculate the hypotenuse by saying equals, and of course it's going to be leg 1 squared plus leg 2 squared And then I need to take the square root of that to find the hypotenuse, the length of the hypotenuse. And what I need to do that to find the square root of a number is I need to raise that to the 1/2 power. So I could do simply 0.5, and that will take the square root of the quantity inside the parentheses. If I run that and then print it out, you will see that the result is 5.0. So none of this should be too surprising. The mathematical operators are pretty consistent with what you expect. Hopefully you'll have no problems. If you have any questions on this, of course, please let me know.